Okay, awesome. We can start. Good morning or good evening to all, and welcome to the Data-Driven Community Virtual Meeting. A few words about the Data-Driven Community. For more information, simply check the community website. I will add the link in the chat in a few minutes once I will give the control to our guest speaker of today. If you will scroll down the main page of the website a bit, then you can see the upcoming event. On the left side of the page, you can notice the information about the Future Data-Driven Summit 2025. The Future Data-Driven is the annual joint conference we are leading and running with multiple data platform user group partners. The second branch of activity we run are the weekly meetings of the Cloud Data-Driven user group, exactly like today. You are more than welcome to contact any of the community board member. Jen Joseph is the founder and co-administrator of the community. Defti Gugori is the moderator and the event organizer. And myself, my name is Ronen Arieli. I'm from Israel, working as a senior consulting in the field of data platform and the architecture of enterprise level system. I am the second co-administrator of the data-driven community, and I will be hosting the session today. Together, we are here to help and serve the data platform community. During the meeting today, please feel free to use the chat for questions and discussions. This is not a conference. We are flexible with the time a bit. This is important for the speaker to know as well. It's a user group. It's more relaxed. So use it. You can speak between yourself as well, but focus on the speaker and our session of today. You can also, and you are more than you are welcome to use reaction. Personally, I love it a lot. It doesn't interfere with the course of the meeting. If you hear something that you love, like, or you just want to clap hands virtually, then feel free to do so. I'm honored to introduce our guest speaker of today, Jared Kuehn. Is very known in the community as a speaker. He speaks in a community event and user group, and of course we have him here with us. So Jared, please share your screen and add a few words about yourself. You can do it better than myself, and you can take the control from here.
Sounds good, Ronan. Thanks for the intro. Go ahead and share screen here. Should show up shortly. Make sure I've got this here too.
Awesome. We can see your screen.
All right. Well, first of all, good morning, good afternoon, good evening, good night, depending on where you are or where you're watching this recording. Welcome to this, and thanks to Ronan and for all the organizers here for inviting me here to talk to you about PySpark, specifically within the context of Microsoft Fabric. All right, Ronan gave me at least a little bit of an introduction, but a bit of an additional introduction in case this is the first time you're seeing me. My name, Jared Kuehn. This is what AI looks like when I tell it to make me look businesslike. This is what AI looks like for me when I tell it to make me look silly. This is when I'm in more of an adventurous mood, and this is what I look like with my full beard, which I'm regrowing right now because I just did a musical production about a week ago and had to shave for the show. So that's what the full beard looks like. Slightly better than what I'm dealing with today. But more importantly than my facial expressions and facial features, this is what I'm hoping to provide for you today. My goal in life is to be a data bard. Now, what does it mean to be a data bard? Well, it's two particular focuses. One is probably more the reason that you're here, technical expertise. So I work as a consultant in the data industry, currently working as a data architect for Baker Tilly. and serving as a consultant there, helping organizations solve their data problems, figure out how to effectively use data at scale. But my specific focus is really about how do engineers, like a lot of you on the call today, or at least I'm assuming a lot of you are engineers on the call, how do I help people be more efficient in the work that they're trying to do? Which is a lot of what we're going to be targeting with today's topic in particular, talking about Microsoft Fabric specifically. The second focus that I have is the BARD part, focused on storytelling. I put a very strong emphasis on storytelling techniques because if we go back to the dawn of time, I'm pretty sure inventions like the wheel, the usage of fire and such predates things like Microsoft Excel, Lotus apps, or even writing things on parchment paper. So at some point, we were able to make significant advancements, and we did so through the use of telling stories. So with that same goal in mind, I'm here to try and tell you a story. Let's have a little bit of fun with this, but more importantly, let's use it to help educate you all on today's topic. Which, again, we're talking PySpark Fabric. Two slightly different focuses, but we're going to be focusing on PySpark, which has been around for some time, specifically within the focus of Microsoft Fabric. And here's the question I'll ask for you now. It'll be the question I encourage you to ask yourself as we go through today's presentation. Fabric is a software as a service offering, which means it's trying to do things for you. So you want to ask yourself this question: what is the benefit that Fabric provides to make my experience with it easier? That's the sort of question we're trying to answer today. I also want to make sure that for those who may see this and aren't familiar with PySpark itself, before we get into Fabric, we'll take a step back, take a look at Python Spark fundamentals, just to make sure that people understand those foundational principles first. Then we'll put it within the context of Fabric with a couple slides. But honestly, most of today we're going to be doing demonstration, actively working in the environment, because I think that's going to tell the story a whole lot better than a bunch of slides will. As Ronan mentioned, anytime you have questions, use those avenues mentioned to feel free to ask them at any time you have them. I prefer to stop while we're in the midst of things so that I can answer questions while they are relevant to the current topic. So feel free to ask away as we go along, and I will do my best to answer them with the knowledge that I have. Sound good? Sounds good. So we start today's story where a lot of people start these types of situations with a question. Especially we work in the data analytics industry, so questions are incredibly important. So aside from the question I asked earlier, here's a question right now. Why PySpark? If you think about the industry, a lot of things are talked about as far as data and the ways that we interact with data, especially for processing and prepping it for analysis. Things like low-code solutions, artificial intelligence is becoming more prevalent. And if you go back further, things like SQL for working with structured data is very popular. R was a popular analytical language. And then you've got something like Python, which especially recently has gained a lot of benefit. And that's where having a conversation with Sven in this early on is where we start the question of why PySpark? And I'm already seeing comments in the chat that's already starting to answer this question a little bit. But Sven asked the question this way: what's the point of PySpark when you've got something like Python already in the industry? And we take a look at that, and certainly Python in recent years has provided a lot of benefit for us. You know, it's a good old third generation programming languages, so being able to do things procedurally with data, being able to create classes and objects and all of those good things in third generation language, we've already got that support. The community has strongly rallied around Python and its usage with data. In that, you can easily see it from the many libraries that have been created to make it easier to work with data. So why PySpark? Well, while Python does provide a lot of benefits for us, and I compare it to Python specifically because it's obviously its closest counterpart in the industry. Python on its own does have a couple of drawbacks, at least if we look at it today in typical architectures. It's more designed, not necessarily that it was designed with smaller data sets in mind, but in terms of the architecture of most Python environments, because of certain limitations, they work best with smaller data sets because Python environments, for the most part, are single node computing. Early on, the Python environment had something called a global interpreter lock, or GIL. That's a keyword. If you want to do some research on that and read up on that after today's session, I encourage you to do so to learn more about it. But the general idea behind it is we like it that our data and our things that are in memory aren't negatively impacted by too many processes hitting those data points at once. The global interpreter lock tries to lock that down. What it innately does, though, is it does kind of push us in a single node, single threaded approach to working with data. And if we look at our architectures in a way where we're scaling up and our architecture just gets to be really, 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 really large servers, this isn't necessarily a problem. But what has the data industry looked to do? Instead of scaling up a lot of times, we like to scale out. Distributed computing. And Python on its own doesn't innately solve for it. Although if you take a look at some recent things going on in the community, certain people, again, talking libraries, are trying to build libraries that support that with Python environments innately. Well, you can go that route, or you can go the other route that a lot of people in the industry have tried to solve it. And that's where, Sven, we need to move away from your skepticism and talk about an approach that has been used to try and solve that. We talk about PySpark. And PySpark, in a nutshell, it's an API for Python working on Apache Spark. So it's trying to give you all the goodness of Python, but in an Apache Spark environment. And because we're doing Apache Spark, this is where we start talking distributed computing. Resilient distributed data sets. That's your other keyword. Look that up after the fact to understand more of the what's happening behind the scenes with Spark specifically. But you can think of it logically this way. I have a very large data set I want to perform 5 operations on. Distributed computing says I'm going to break my data into 8 chunks for 8 compute environments that I have available. Each one is going to get a set of data and those same 5 operations. And then it's going to perform those operations on that focused data set with its own compute. And then everything gets collected back into a single centralized architecture. That's what you get with distributed computing. That's why PySpark. We're trying to solve bigger data problems with a distributed solution. And again, because we're working in Python, the goal here is we're still trying to do library supported development. Before you develop anything in Python or PySpark, you should be asking yourself the question, has anybody in the industry built a library that makes what I'm trying to do a little bit easier? And ideal cases, especially when you're talking data, there's a lot out there to support you. So that's why PySpark, and that's what brings us here today, at least to talk about the PySpark side.
There is a
Alrighty.
good point in the chat. You might want to respond regarding the single thread or multi-thread using Python and using PySpark.
Correct. So that is a good point, and thanks for bringing that up. So really, the goal is here that when we're moving into Spark, we're trying to move into a world where we're going from single-threaded to multi-threaded. It's still trying to maintain the same thing because if you think about it, the data is still going to a single compute area. So we're still getting the same sort of control, like we want to avoid dirty reads and writes, but at least now we're starting to head in the direction of multi-threading. We're starting to head in the form of distributed computing. Gives us a lot more flexibility of how we can scale out our architecture versus, like I said, trying to build a really large server and scaling up, which for some organizations that doesn't always make the most sense. So good calls for that. Appreciate that conversation in the chat. Let's keep that going as we have today's session here. So again, this is about like intro level information. So to make sure that nobody's lost about with some of the things I'm going to be sharing in demonstration today, I want to make sure everybody at least has a strong baseline of how to read Python code, just at least to get an idea and a feel for the language. Because if you understand Python and how Python is structured, you will innately understand how PySpark is structured because it's just a Python API. Okay? So, important things to know about the Python language in like 5 minutes. First of all, hashtags. Incredibly important, not just for social media. For the Python language, hashtags are how we do our basic single line comments. And I'll say at least most times, even for multi-line comments like you'll see on my screen, a lot of people typically prefer going with the hashtags for that. There is a way that you can do multi-line comments through the use of multiple quotes. Me personally, I'm not a fan of it. Personal preference because it turns my comments red. And at least I like having my comments consistently green. But again, that's at least depending on the IDE that you work with. Other things to note. Import. Important word means we're talking libraries. You can see that this very top section here, import pandas, which is a very popular library about data. We'll get that in a little bit. So anytime you see import, that means somebody is bringing in a library. And this is, again, most scripts, you're probably going to want to see more imports than not seeing any, because that means somebody's bringing in a library to make your life a little bit easier. Other things, third generations. We want to do things like object-oriented programming or creating functions. How we create functions in Python, DEF. DEF defines a function with some notation like what you have here. And the important thing to call out when we talk functions, amongst other things in Python, is something that innately comes in with formatting. Indents are necessary. You can see in my function definition here, I've got this line underneath it that's just doing a basic hello world, passing in a name parameter. In a case like this, the indent is absolutely necessary. I can't define this function without this being indented. If I unindent it, this is going to start throwing errors at me. And that is ultimately what defines the scope of the function. So as long as the code is indented, that's the definition of the function. Once we get to the next line and it's unindented, that defines the end of the function, and we're moving on to doing something else. So hopefully at least you don't mind indentation, because if you have issues with indentation, you're going to have issues with Python and with PySpark. Praise be the data frame. I say as kind of a joke, but admittedly, data frames, if you're looking to get into this and you haven't heard about data frames, do some reading up on data frames, and especially this pandas library up here. Data frames you can think of as just a simple Excel single sheet spreadsheet. That's all a data frame is, rows, columns of data. And what you'll find here for PySpark, but I'll also say, especially when we talk Fabric and some of the things that I'll show you today, Fabric is going to make your life easier when you work with your data within data frames. It gives you a couple of extra bells and whistles that I'll show you today. So get familiar with data frames, because data frames is going to be your main workhorse for transforming data within the language. Variables. This is something I want to talk about specifically because if you're coming from like a SQL background or other languages, Python is a little bit more like PowerShell in terms of how it handles variables. Variable definitions are very simple. You define a name, and then an equal sign, and that's it. Variable equals whatever you pass it in. It's like, what about all those data types? What about all those things I want to define about it? That's all defined by what you pass into it. And you can actually change a variable's data type by passing in different values into it. So hopefully at least your workflow is not too stringent about having specific structures in mind. If you do need that, there are ways that you can define specific structures and specific data types within data frames. I'll have to double check with a demo. I believe I covered that, but at least expect that this language is going to be very flexible when it comes to data types. But it still gives us some cool things to do depending on the data types you're working with, such as strings. And this is one I want to call it because it's a weird notation, but it's a common notation I see in Python. It's specifically this greeting line here equal to F, and then it looks like it's doing a string with curly brackets and such. That F's got to be a typo, right? No, in this case, F the letter is a keyword in the Python language. Yeah, letter being a keyword seems a little bit weird, but it is in fact a keyword. This is indicating that when I use curly brackets, I'm referencing a variable outside of this line of code, and I'm trying to pass in a value dynamically into a string. Do we work with data? That comes up quite a bit. So I at least want to make sure we cover that if you see this F here, that's not a typo. That is genuinely part of the language. And then at least last thing, I mentioned formatting, that indentation itself is important, but anytime you're learning a new language, I encourage people take a look at style guidelines that are available out there to come up with a consistent way that you're going to write your code. And the one that at least I would encourage for Python, and again translates into PySpark, the PEP8 guidelines has some pretty good consistent ways of defining your code. If you don't like at least the way that one is specifically structured, this is another area that has been heavily supported by the community. So just take a look out there, search for style guidelines for Python. You will find others out there. And like any code, as long as you keep your code consistent, consistently formatted, that makes it innately more readable and will support you, hopefully, collaborating with others, which Fabric is going to enable you to do quite a bit there. All right. Next, we talk. All right, we're going to switch to admin, so I'm going to quick check here. Let's see. Session materials. Yep, I will get that for you later on. Um, ooh, good resources for explaining data frames. Awesome. Thanks you for sharing that in there. All right, so that at least covers some foundational things in terms of Python. Now we're going to transition into talking about Spark, and this is where we're going to start talking Fabric. So logically, Spark is again distributed computing. We're going to have multiple nodes. Each node has its own unique compute. It's going to try and perform its own operations, which means it has some innate storage included into it. Fabric is going to want to make it so that you don't have to worry a whole lot about the architecture of Spark beyond that. Now, obviously, if you do work in Spark in other areas, there's a whole lot of extra things that go in as far as configuring your nodes, your Spark clusters, and doing specific configurations. A lot of that translates here, but this is where a lot of this is. Fabric is trying to make things easier for you. And here's where some things it's trying to focus more on simplifying administration than it is giving you all the bells and whistles. We start off at least with talking about some things you should talk about with your Fabric admin. Because I'm assuming if you're seeing this, you're probably not going to be your Fabric admin. So there are certain things you're going to have limitations that you personally can do, but talk to your Fabric admin about these things, and they can work on configuring Fabric to make your life a little bit easier in a couple of areas. First thing you want to talk about with your Fabric admin is defining your Spark pools. When we talk Spark pools, we're defining a pool of compute resources. So a pool of nodes that then get used by your process. And here, main thing you want to talk about with your Fabric admin is what is the capacity that you are working in. And at least if you haven't looked at Fabric capacities, think F2, 4, 8, 16, keeps going up by powers of 2 to F2048. You want to know that number because you take that number, you multiply it by 2, that gives you at least at base, I'm talking about bursting and throttling and those other parts of Fabric, but that essentially tells you the total number of vCores you have available to work with and to create a cluster from. So you want to know that from your admin. From there, you'll want to have a conversation with your admin of creating an environment. An environment you can think of where Spark pulls as the hardware. An environment is a configuration which defines your Spark pool, or at least a Spark pool that's already been configured, but then allows you to create some additional things to have things innately in your environment. First of all, runtime. We're talking things like Spark. Spark, the language, has its own versioning, as does the Delta table standard. Both of those things you can set to different values in your runtime. And that will change in certain ways how you interact with your data and what keywords and such are available within the language. So you want to make sure that it's set to the appropriate runtime that supports the type of workload that you plan to do with Spark. Other thing, talking about libraries quite a bit. Fabric innately is going to have a lot of libraries innately loaded into the Spark environment, but it's not going to have an exhaustive list of everything. Not only that, it's not going to cover situations where you want to define custom libraries of your own that you might want to use. It's not going to innately have that in the default environments, but you can create a custom environment which then already has either libraries from places like PyPy or custom libraries that you've built yourself can get loaded into the environment. And then when you start up your Spark compute, those libraries will be ready, waiting for you, and you don't have to load them in every time you run your code. Important reasons to talk about this, and again, looking at this from a user perspective, is where you want to keep an eye on getting this message at the bottom of the screen when you run your Spark workloads. The Spark job can't run because you have a hit a Spark compute or API rate limit. That means right now your process is trying to provision compute. So again, if you haven't worked in Spark before, we might come from more of a database world where typically we expect, aside from like working with cloud structures, auto pause, things like that, that is just, I've got a database. Database has storage and it just has compute whenever I need it. Spark changes that paradigm. Spark is more of the mindset of only provision compute when you need it. And then when your process is done, let's deprovision it because more than likely you're provisioning more compute and more compute can be costly. So we have to get ourselves in the mindset here. We're working in Spark, which means my compute is not innately available. I have to provision it. And that's where you might try and then run a workload and say, you've hit a limit. Well, that's because at the point your process is running, it's likely trying to spin up a new cluster of Apache Spark, and it can't do it. There aren't enough resources available in your capacity. Who do you call then? Fabric admin and figure out what other workloads are running right now, or if somehow you were able to create a workload here that is too large for the environment. But more often than not, if you hit this error, there's something else going on in your Fabric environment that is taking up some of your Spark compute, and what you're trying to provision is too large for what is remaining. All right? Let's see.
The question in the
Oh,
chat, can you dynamically configure the compute?
can you dynamically configure the compute? That honestly, I'm not sure. My guess would be no, because I'll show you in the UI in just a moment. The buttons that you have is essentially picking an environment and picking a run button that starts the compute. You don't really get a whole lot beyond that. So the most dynamic you can make it would be if you define different environment configurations with different cluster definitions associated to that environment, and you can pick and choose what makes the most sense. For the most part, it'll be, if you can do that, you'll be trying to override a default, which each Fabric workspace will have a default pool associated with it. And then you would at least need to try and make adjustments on that. I'm trying to think actually if I worked through that. I'll show you at least what the UI gives you as far as controls on it. And once you at least understand that, then it would be trying to figure out how programmatically you might be able to adjust that. Let's see. Another question. In a real-time project, who controls this compute allocation for a developer? Can you at least clarify that question? Are you talking about compute allocation for a developer as far as their development environment? Or are you talking more as in like who determines the amount of resources within your production environment? Please give a moment and we'll see. Okay, we're going to be heading to demo, so I'll start shifting to the demo environment. Okay, in development environment. All right, so compute allocation, that ultimately would be something controlled by your Fabric admin or whoever, to be specific, who is administering your workspace. So I can actually, when we get into the demo environment here, I'm pretty sure I have access to this in this environment. So let me at least show you quickly the where at least the controls for this mostly exist. When you're talking Fabric, there's like two levels of administering things. One is like the overall tenant level, and then workspaces is really the next level where you begin administering things. Within a Fabric workspace, I'm going here under the workspaces settings, and then there's a section for data engineering and Spark settings. And this is again where if you're an admin to your workspace, you would have these sorts of controls in place. For the most part, it's again defining the default pool for the workspace. So here I'm just using a basic starter pool, and it gives me information about memory optimized as far as node family, which right now memory optimized is the only option. Presumably there are more options coming to Fabric down the road. Why they gave us the option and there's only one thing to select, I don't know. I'm not a UI person. Node size. So here you'll be able to relatively pick the size of nodes that will exist in your environment. And there are if you look at Microsoft Learn documentation, you'll find where the node size translates into actual size of memory, size of storage, and number of vCores are defined within your node size. And then ultimately the number of nodes, which is the number of, in this case, medium nodes. Medium or node sizes, I believe, go anywhere from small to, I think, double XL is the largest node size. But again, it is all relative values that translates to actual physical compute constraints covered by Microsoft Learn documentation. Within then your workspace, this is where you can also define your environments. So again, if you have access to this environment, take a look at that. If you want to do things like jobs, high concurrency we'll talk about when we actually get into demo here. I'll explain that in a moment. So that's for the most part the controls you'll have. For the most part, it is again workspace by workspace. All right. So now we're in Fabric. And anytime we're in Fabric, we need to create a new item. We'll be using a notebook that I've already created previously, but if you're in the Fabric environment, you want to create a new notebook, just hit this nice new item button and search for notebook. And you're going to get 4 options back. There's a get data notebook, a prepare data notebook, an analyze and train data notebook, develop data notebook. Why do I have 4 notebooks? This is more the way the Fabric UI manages things, where each section it's trying to give you all of the capabilities that support this type of workload, in which case notebooks can get data, they can prepare data, they can analyze and train data for ML situations, and you can develop data using notebooks. What's different with them? Nothing. These are all the exact same notebook, same experience, same everything. The only difference is they're in a different grouping. So pick whichever one makes the most sense for you and go ahead and run with it. Once you get that up and running, that brings you into this lovely environment, which gives us a bunch of bells and whistles. So first thing, let's talk about at least the base experience, the code itself. If you hover over here, you'll notice I've got plus code, plus markdown showing up, and then I've got a bunch of segments and such going on here. So if you've worked with Jupyter notebooks before, and you're wanting to work with PySpark within Fabric, expect to work in the Jupyter notebook experience. For more automated things, there are, like, you can do Spark job definitions and such, in which case you're not getting this UI experience. But I would say those are more for like specific automations that you're trying to do, versus this, which I'm going to be focusing on more of a developer interactive experience when developing PySpark code. Quick rundown then, if you're new to Jupyter Notebooks. Jupyter Notebooks is cell-driven development. So I'm breaking up my code within a singular file into individual cells. The benefit that comes in here is twofold. One, I get different kinds of cells. This initial cell that I have here, which has all this fancy text here, is a markdown cell, which lets you do more elaborate documentation. And then the second one down here looks more like what we'd expect to see. It's a code cell. Lets us do more code things. Second benefit of working in a Jupyter Notebook type of situation is I can now run individual sections of code piece by piece and debug them individually, rather than having to debug my entire script at once. So suppose you've got like 4 cells of code. The first 2 cells take about 15 minutes to run for your workload, and you're debugging cell 3. You don't want to have to keep running that 15 minutes of code every time. What you can do here is you can run that once, and once that's done, you can just focus on running cell 3 as many times as you want based off of the output of what cells 1 and 2 gave you. Gives you at least the opportunity to work with larger workloads and focus on the areas that are most important to you for the work you're doing at that moment. So at least best practice there, break your code into cells as it makes sense and think about it from that lens of how am I going to debug this? That'll save you a whole lot of time when working with your PySpark workload here. Looking more specifically at my markdown here, it's giving me some notes on some of the things I need to make sure I show you about, again, what does Fabric provide that makes it easier to do my work. First things it wants to talk about is Lakehouse Warehouse. So first thing we need to deal with when we're building out a new workload is I need data. I need a data source that I'm going to then do something with. This is where Fabric is trying to make your life a little bit easier. What it is trying to do here is it's giving us an explorer, like many IDEs do. Left side is where we've got very important information to us. And in this case, this explorer gives us data sources, which I can hit add data items here. And I can either create a new lakehouse or connect to existing sources. Hit checkboxes on a number of these things here, and I get a connection from those data sources into my notebook here. What does this allow me to do? This is where I now have to do the demo that everybody is legally obligated to do every time you see somebody do a Fabric Notebook demonstration. Watch here. I'm going to go into my lakehouse here. Again, talking Fabric Lakehouse. And I'm going to take this table over here. I'm going to drag and drop it over. Okay, not all that exciting. What did it do? All right, it generated a little bit of code for me. What is it doing? It's generating code that tells me what at least is the easiest way to get data out of my lakehouse and into my Fabric notebook so I can start doing things. By default, at least using the PySpark experience, it's going to write a Spark SQL statement that's doing a select, and it does do a default of limit 1000, so it's going to give you top 1000 records. Keep an eye out for that if you're going to use this. And then writes a basic display function, which is the fabric-y way of essentially a really fancy way of displaying your data set to console. Okay? So this is at least the basic experience here. Note, though, and this is where I don't want to tangent too far off of capabilities, but it's something I want to call out. We take a look at this list up here. In the notebook experience, we're focusing on PySpark today, which is just one of the many ways you can take advantage of Spark within Notebook and within your Fabric experience. You do also have the option, if you want to just write straight Python, you don't want to deal with the Spark experience, you can do Python. There's also this T-SQL experience, which is T-SQL. You write T-SQL against it. Just know that for each of these, there's sort of a assumption of what type of data store you're going to interact with when working with these specific languages. Everything up here, let's see, there's a way to write. You're expecting to work with Lakehouse. Oh gosh, I wrote text on text. Who does that? All right, so the top section here is Lakehouse. All right. So here expect that not necessarily that you can't access warehouses with this experience, but the UI isn't going to give you a whole lot of benefit here. Python kind of does both, lakehouses and warehouses. All right, so we'll give it a B there. T-SQL is working with relational data, so where do we expect it to work with? Warehouses typically, although technically, if you've worked in Fabric, you know Fabric has lakehouses. Lakehouses have SQL Analytics endpoints. The T-SQL experience here in the notebook can hit the SQL Analytics endpoint. Just know then it is truly the analytics endpoint, which means read only. You can't manipulate the data within the lakehouse that way. So we're sticking up here, at least in this land there. And again, this is also defining the default language for the notebook. That doesn't mean I can't switch between languages. So for example, I can hit plus code here. And down here in the bottom right here, it says PySpark Python. If I open that, I get pretty much the same options as above. That means within this notebook, I can switch languages if it makes sense for me to do certain steps and say Spark SQL. You can switch those things. You also, to consider cleanup here, you get the benefit of this lovely toolbar here, which is cell by cell and gives you a bunch of things that you can do. The one that I'm going to focus on is this trash can, which I'm going to delete this cell because I don't need it in my workspace. All right, next thing we need to talk about, connecting to a session. We're going to connect into a session. Why do we need to connect into a session? Again, we're talking Spark. Just having the notebook open doesn't mean I have compute available. I have to start it up with this connect button up here. Connect gives me two options here. Standard session, high concurrency session. What's the difference? This is more from the developer mindset. And think of it this way. A standard session Any compute is isolated to this notebook exclusively and your developer experience with it. High concurrency, if you as a developer expect to work with multiple notebooks at once, like it might be a workflow where multiple notebooks are interacting with one another, you might be editing multiple notebooks at the same time. A high concurrency session allows you to connect multiple notebooks to a singular session. That's the distinction between the two. Before I start this up, we've been talking about those configurations here and some of the options there. This is where, before you start up your compute, you have the option to pick your environment. And at least in current environment, I just have the default environment. I don't think I have I do have some other environments created as well. And these environments do have different cluster configurations to them. So I can pick a different environment for this notebook, but I'm going to stick with the workspace default. All right, let's hit this up. Now, if you worked in Apache Spark, we might be sitting here for a couple of minutes here in something like a Databricks environment. This thing started up a session in 4 seconds, and I just crossed out 4 seconds here. There's some mystery going on here. And if you've worked in Spark before, and this is where you're looking at it specifically within the context of Fabric, most times Spark sessions take a couple minutes to get up and running, depending on size of cluster and the configuration of the environment. How did we get something up and running in 4 seconds? Something I want to call out to make sure nobody's getting sales pitched on the Fabric experience. The secret here is this workspace default, which I'm using the starter pool configuration. When you're using the starter pool configuration for your workspace, I'm not really starting up a brand new Apache Spark cluster. I'm actually connecting to I'm connecting to one of a large farm of Apache Spark environments that are already running on Microsoft resources using the default configuration. So when you start it at least and you use the default configurations, you will get sessions up and running in consistently somewhere between 3 to 10 seconds. That's because it's not creating a new compute environment. It's just connecting to one that already exists, and that's the one that you're interacting with. Lesson learned here, though, is then if you do a lot of custom configurations with your Spark configuration, with your Spark cluster configurations, more things going on in terms of environments. Once you start doing those things, you'll get more of the typical Spark experience, which is starting up a session may take a minute to multiple minutes for that session to get up and running. In this case, I'm doing default settings, so I don't have to worry about that. And because I don't have to worry about that, I am getting a simpler experience. But that is, again, default configurations, not if you choose to do things more custom. I know that I've got my session up and running because the connect button turned into this. Green means things are running and that I've got a standard session going. Last thing is then, how do I actually run my code? Well, I can run all these cells individually. Each cell is going to have its own run cell button here. I've got a run all button up here if I want to just run all the cells one after the other. This demo is more intended to be run one after the other. So just to show the run cell experience, I'll hit that. We'll wait a couple seconds, and what we should see here is it does a top 1,000 of taking my data out of a delta table and putting it into DF, short for data frame. And there you go. So think about that. Sometimes you're working in environments and getting connected into your data and being able to start doing with it can take a lot of time, extra configurations, connections, all of that. Fabric is trying to make it easier where if your data is stored in Fabric, if your notebook is in Fabric, Fabric knows where Fabric is. You add a data source into your notebook within 5 seconds. You drag something over. Takes you maybe a minute from connecting into your data source and getting your initial data set in. That's the type of benefit that Fabric is trying to provide. But of course, that's at least reading data. Writing data, it's also trying to make that easier for you too. For sake of time, I'm not going to run this section here, but just to show you some of the benefit that Fabric provides here by connecting the lakehouse like we did at the start of the demo here. This is a pretty common statement in the Python PySpark notation where I'm trying to take data out of the data frame I loaded in the previous cell and I'm trying to write it, which means I'm writing it. I'm trying to determine overwrite, or appending data depending on your use case. The format of it, we're targeting delta. And then here you can see I'm doing very nice, simple relative path versus this line below it, which has a really long ABFS path that goes off the screen. These two lines of code are doing the exact same thing. The bottom one is looking at the absolute path to get from your notebook to the data storage. This one here is a shortcut and is a relative path that is pointing to the lakehouse I connected to in the Explorer. But this notation only works if I've got that notebook connected in. It does not work if you have no notebooks or if you don't have any lakehouses connected in. If you don't have any lakehouses connected, then this is the notation you need to use. And the third line at least showcases that with simple adjustments, you can write to delta, which I would say you're working in Fabric, so write to delta when you can, unless it makes sense to do other ones, in which case you can write to CSVs and the like. So basic read-write capabilities, trying to keep things simple with connecting in your lake houses here for a basic use case here. Pause a moment and then we'll get into, no, actually, let's run the next section here. Trying to be sensitive of time. And then I'll pause for a moment for questions. So here's a demo set that I created that I wanted to use for today's demo. Oh, geez. Although I didn't really look at this one too crazy. Yeah, we've got some data quality problems here. So I created this data set. I'm a big fan of Weird Al, but I'm not like this big of a fan of Weird Al. And gosh, we've got some issues going on here. Like there's duplication clearly. Age is a decimal point. Oh, I knew I should have checked this data set before I did this demo. Yeah, Weird Al is taking over my data set. That's a problem. Okay, so let's talk about this. Like, what do you do when your data is not pretty? I mean, especially maybe if you're somebody watching this and you're brand new into the language. Gosh, what do we do about this? Um, well, I'm brand new to the language, so I could go in and read in a bunch of books about how to do things. And certainly to learn the language and to master the language, look at your resources, learn the language. This is where Fabric is also going to try and provide its next bell and whistle to try and make your life a little bit simpler with a tool called Data Wrangler. We're going to go ahead and load this. And I'm going to take a moment to answer questions while this loads up. And then we'll explain what Data Wrangler is. All right. Formatting tools. If you're looking for formatting specifically within Fabric, I don't remember. There is an AI in here. You could try and use the AI capabilities in here to do formatting. That's probably going to be your best option. It's not going to have a built-in linter if that's what you're looking for. Under edit, is there an option to add that? Oh, we can take a look at that in the UI. Trying to remember that. Jupyter extensions. Yes, I believe Jupyter extensions might work in here. Yes, in the browser, can you add extensions? Not really, unless it's a like in this case it would be an Edge extension. Um, you can and this is a capability with Fabric that has been getting better as time goes on. You can open the notebook within VS Code. And then if you have extensions there that simplify certain things, you have access to those via VS Code, and you can manage your notebooks there. Auto scaling for cluster compute like Azure has for node pods. There is some auto scaling available. There's a couple ways that you can do it, and this is something that is evolving as Fabric is evolving as a product. The easiest way you can do it is when you define your uh, pools within your workspace, you can, there's a checkbox that allows for dynamic allocation. So you can choose to dynamically allocate, in which case it will allocate clusters as it determines it needs it, or you can uncheck it and then whatever you define for the cluster, that is automatically what is provisioned. Beyond that, there's some additional things coming out for Fabric right now where there's going to be some more capabilities with scaling. It's also going to be giving you a billing model where you can manage your costs of the Apache Spark clusters in a separate bucket outside of your Fabric capacity. So if you look at, trying to think of the name of the link, like Apache Spark auto scaling and Microsoft Fabric, you should find, I'm pretty sure that is in, I believe that's still in preview. I forget if it's in public preview or it might be in public preview now. I'd have to double check, but I'm pretty sure that's in public preview now. So there will at least be some more capabilities there. Oh, yeah, and yeah, there are things out in the Fabric community, so thanks for the call out on that. Yeah, please go and vote that out. Never too much Weird Al. Yeah, Andrew, there's no such thing as too much Weird Al, but I don't want him taking over my data set. We want clean data at least. And believe me, one record is enough to encapsulate Weird Al. So, all right, things have at least loaded in here. So let's at least talk Data Wrangler. So clearly we've got data quality problems, and maybe I'm new to the language. So how do I solve for this? This just doesn't seem like something I really want to deal with. Well, you can either like read all those books, or you can use something like Data Wrangler. What is Data Wrangler? Think of it this way. If you work in Power BI and you're pulling in data from Excel documents or tables or whatnot, at some point you hit Power Query, which is a low-code experience that allows you to transform your data for your report. And then that transformation is then converted into M language, which is then what the engines behind Power BI use to take data from source and transform it to get you to your final data sets that you use for your reports. Data Wrangler is the exact same low-code experience, but instead of targeting reports and semantic model datasets as your end goal, here we're targeting code that is written in either PySpark or Python that can then do the data manipulation of data within a data frame. Told you we'd come back to that whole data frame thing here. So what you saw me do there before is I loaded my data into a data frame by running that cell, and then I hit Data Wrangler and I told it to point to this data frame. This gives me this experience where we can do some quick cleaning up of data. So clearly we've got duplicates. So we're going to try and deduplicate the data. And like Power Query, this is also going to try and do it step by step. So here it added in a step that said, okay, this is the code that I need to run to drop duplicates. For sake of time, we'll just try and clean up age because we've got 3,900 different values for age. I don't think there's anybody out there that's almost 4,000 years old, so clearly these decimals are a problem if we want to do things like age bucketing and whatnot. So I need to find Let's change column types because clearly we don't want this to be decimal value. So I'm going to try and turn this. We'll go age. We'll try and turn it into integer. And it actually gives me an error. So like it should do, it's going to warn us if we're going to try and do transformations that aren't going to work well. So here it's already giving us a message that says that this is not going to work. You're not going to be able to do that. So, okay, that makes sense because it's just a basic object type. So let's try and make it a little bit more specific and let's do a float value. Okay, let us do that. So we're at least in this data type. And then I would have the options of, okay, I can round. So I can round the age to no decimals. And I can add that in there. And then let's see if we can do that. Change the column type of age again. Now can we see if we can get it into our nice integer value? Okay, now it'll let us do integers. So obviously part of the answer here is let's make sure our source data is a little bit cleaner than it is right now. But let's be honest, we don't always deal with clean data to start, and sometimes we have to clean up our data ourselves. This is a way to do it. And now, like that Power Query experience, I've now got a bunch of steps to take that messy data and clean it up. So we'll call that good for right now. We'll hit Add Code to Notebook. And this is where I have the option of, by default, Data Wrangler is going to define PySpark code. But if I want, I can hit this, and it's going to generate Python code working with a pandas data frame instead of PySpark, which is going to work with a Spark data frame. We'll hit both, at least for sake of argument. And it adds it in as two brand new cells with the code that I had above. We'll go ahead and run this quickly. Well, actually, this probably isn't going to run quickly now that I think about it because this is running on, I think this has got like 10 million rows in it. So we'll run this one that tries to simplify the cleaning procedure. And there you go. It gave us the same results that we defined in Data Wrangler. Alrighty. Then the last thing, so UI experience, a lot of benefits there. I'm not going to even have time to really showcase much in terms of Copilot. I've been at least working with a Copilot experience in here. If you work with code, it's going to be that sort of Copilot experience. It's still in preview, so depending on your prompting situations, is it going to know the Python language and how best to do things compared to something like GitHub Copilot? Not yet. The model is still improving, but it will at least know things about the Fabric environment and will be able to help you that way. And in that respect, I would say this Copilot works really well to help you understand your environment and what you can do with it. So what to do when Weird Al's taking over your data? Consider using Data Wrangler. Last couple things is let's talk about some more admin things or maybe some more code-centric things. One thing I haven't really talked about is orchestration. And there, you might work in a multi-notebook environment or situations where this notebook needs to be orchestrated with other processes. Fabric, you can define what's called a parameter cell. You can have one parameter cell per notebook. All this does is it takes whatever variables you define in this cell and exposes them to external processes, be it other notebooks that could call this notebook, or things like pipelines, which could also call this notebook and pass in values to it. Both work with this parameter cell. Just note that, again, the notebook, working in more of the Python world, leaves the definition of variables very loosely defined. So make sure you check your data types and you know what to expect out of a parameter before you take an integer, what you expect to be an integer parameter, and pass it in text. You won't notice the error until you actually run the notebook and the orchestration, and then it's going to start throwing errors. So just know that up front. Last thing you want to do here to at least round out the demo is let's talk libraries. So data frames is obviously a popular, like PySpark has its own libraries for creating data frames. Pandas is a popular library for data frames. There's a couple of libraries that are specific to working within Fabric that you're going to want to know about. And I want to call them out quickly here. First one is SempY, SEMPY. You'll also hear one of the sub-libraries here that is really popular nowadays, Semantic Link Labs, is part of SempY. The initial intent of SempY, as the name somewhat suggests, is working with Python or PySpark code with semantic models. And that's where, if you're interested in that type of workload and working with your semantic models with this type of code, take a look at SempY, take a look at Semantic Link Labs. The library has a whole lot of capabilities to support you there for both profiling your semantic models and making adjustments to them. In this case, this is a very simple use case of I'm calling one of the APIs that's supported with SempY and lets me identify finding where one of my lake houses exist. Another one you're going to want to know about is this example here, Notebook Utils. This used to be MS Spark Utils. I think most of the documentation calls it Notebook Utils now. This is a must-have for people working with lake houses and working with PySpark. Essentially, this gives you functions that make it really easy to work with your lakehouse storage. For example, it's got some simple calls for being able to list what exists in a particular directory in your lakehouse. mkdirs makes directories, so you can create your file structures within using these notebook calls. Moving files, it's got things like that. And this is showcasing an example of where I built a basic routine that allows me to identify particular directories in a lakehouse, create an expected architecture of the subfolder structure I expect to have in that environment, and to be able to move files in between that structure. Could you write all of this without notebook utils? Yes, you could. But this is, again, where Fabric is trying to make things easier for you, and this is one where there's not a whole lot of benefit in you trying to write this sort of stuff yourself. So make use of what it innately brings to the table. You'll have a much simpler experience. Let's see. I think that's mostly what I have prepped for demo. Let's see. Okay, some people need to jump off. Hopefully, at least the recording captures some of this. Let's see. Okay. Doesn't look like any additional questions there, so let's go ahead and wrap up with just a handful of slides here. So we covered a lot in a very small period of time. We talked about, again, UI features. So what are the things that Fabric brings to the table? UI features makes it so that ideally your Fabric admin defines a couple things for the environment. You as a developer don't have to do a whole lot of pip installs or those types of configurations. Markdown cells for documentation, those connections, quickly getting from connecting into your data, focus more on transformations. Once you do that, reading and writing data is very nice and simple with those relative paths. Data wrangler, you got parameter cells, you've got libraries. A lot of that support is there. But obviously a whirlwind of information. So I'm expecting you're looking to continue your journey beyond this. How should you continue your journey? If you're more of a self-learning type of person, you're looking to learn the language especially, the built-in data wrangler and Copilot is a great place to start if you don't have other resources available. So consider using those on top of any reading that you might do. If you're looking for those more curated resources, YouTube has a lot of information out there, both things that are more programmatically focused, so learning Python on its own, Programming with Mosh, great channel for learning a lot of things in the Python space. He has a really good video, Python for Beginners. Learn Python in 1 hour. You will learn a lot about Python in 1 hour. He gives a lot of content within that time frame. If you're looking more Fabric specific, the two channels I take a look at, Tales from the Field is a great channel for Fabric in general, but especially for the notebook capabilities. It's a channel run by a number of Microsoft staff, people who are closely connected to the Fabric product teams. And likely when you're hearing announcements at FabCon or at other conferences, they're the ones first putting out videos on demonstrating how these sorts of things are going to work. Also do a bit of self-promotion. DataBard, not just somebody as a public speaker. I also run a YouTube channel where I talk about some of these types of topics here. So check out my channel for things like that. Make sure at least you're getting out into the Fabric community. So things like LinkedIn has Microsoft Fabric Learning, Microsoft Fabric Community. Get connected out in your data communities. Fabric is a pretty popular topic, so imagine to get out there. And again, you heard me talk about Microsoft Learn out there, a couple points. A lot of extensive documentation out there for things like notebook utils especially, and a lot of community blogs. There's a lot of community discussion going on in Fabric. A lot of people who are trying to push Fabric to be better, especially for notebooks. This is a popular area. So get out here for learning, but also say somebody shared a link about the Fabric Ideas page. Take a look out there and see what people are proposing for improvements to notebooks, because it's a good experience. There's a lot of room for improvement, and the more we get people voting on that, the more Microsoft is going to improve those areas, and it's going to be an even simpler experience for the developer than it already is. And that's what we want to see out of Fabric working with PySpark. Brings us kind of to the end of today's story. So here's my, at least if you're looking to connect with me, the QR code goes to my YouTube channel if you want to go out there. If you're looking for something that's a little bit fun, I have a couple of, I like doing theater stuff in in my spare time. So search for Report as a Service. It's a fun thing out there. But other than that, I'll open it up for questions.
Yeah, I want to say something. We had in Cloudera CDH Hadoop. We play a lot with PySpark. And the issue is, how to play with PySpark and to tune the nodes and to balance it. My feeling, according to your letter, that when we are going to Fabric, we cannot control it. So, for example, we have a lot of programmers who are on the cloud with GPUs. And the programmer has no control and can grow your bill to $1,000. So my feeling is that we cannot balance here the nodes. The nodes, the compute, it is not controllable. And when you're dealing with programmer, you can go to a big bill. And that's my feeling. Correct me if I'm wrong.
Nope, you are spot on, and to be honest, not the first time that I've heard that. It's where, and this is where again I think the growth of the product is, if that is something that is a genuine concern for a large part of the populace, we're probably going to have to do a lot of encouraging on ideas to get ideas on there strongly upvoted to address that, because innately, think of it in terms of trade-offs. Any tool, anything that we work with always has trade-offs. Some good things for it, some bad things for it. Fabric, the benefit it's trying to provide for you is trying to make certain things easier, so you're focusing less on administration, more on development and getting things done. But innately, the trade-off that comes with it is, yes, in some situations, your workloads might need more fine-tuning to get the performance out of it. And that's where, at least in current state, Fabric isn't going to necessarily going to give you a lot of those controls, because its goal is to try and make it simpler so that you're not having to deal with those bells and whistles. So I think at least, like, I get at least their point about making things simpler, but I think that's where, too, if we get enough people out in the community advocating for that, I think there's opportunity to change that for those who want more of those controls beyond doing like just basic spark.conf.set and doing configurations using those types of calls.
Another thing, another recommendation, and from the academy and deal a lot with AI. We are using, by the way, Kaggle of Google and Kuehn notebook of GPUs Google for free, by the way, and practice. By the way, it's also a good start. And by the way, as you said, there is also a lot of substitute for the data frame because it's not so efficient in a big data cluster, etc., etc. So this is another recommendation.
I need to cut you for a second. First of all, I want to thank everyone that attend this meeting. And of course, thanks a lot for Jared. It's a great session. You have great responded on the chat as well. After the meeting, I will contact you. You can send me all the social materials that you want. I will give you a link to upload it, and then we will be able to share it with the community. This means your presentation, file, code, whatever you want to share. Okay? So again, thanks a lot. And I remind everyone, we meet almost every week. So just follow us, and we will see you next week.
Thank you.
Okay? Thanks a lot, everyone. We'll see you next meeting.
Thank you for the opportunity, Ronan. Greatly appreciated. And thanks everybody for your attendance.
Thank you. Bye-bye, everyone.